Hello, incoming Algebra II Adv student. This is John Lasky speaking. There's a lot that we learned in algebra class, and I just wanted to help you with it. So, from the broad concept of polynomial functions, I'm going to be talking about first determining whether an equation or a function is even, odd, or neither algebraically. And this was a lesson I feel that I excelled at. So our first equation is b of x equals x to the fifth power minus 5x plus 2. So the even form of that equation would obviously be x to the fifth minus 5x plus 2. The odd form would be negative b of x equals negative x to the fifth plus 5x minus 2. So to determine whether it's either even or odd or neither, you put negative x in, so it'd be b of negative x equals, in parentheses, negative x to the fifth power plus 5 times negative x plus 2. So then when you factor it all out, it would be b of negative x equals negative x to the fifth minus 5x plus 2. And as you can see, neither the even nor odd version of the function are match this equation. So b of negative x is not equal to b of x, and b of negative x is not equal to negative b of x. Moving on to our second equation or function, it would be x to the eighth power plus 63x to the fourth power minus 3. And keep in mind, I'm doing trinomials here, but not every polynomial function is a trinomial. That's just how I did it. So the even form would obviously be g of x equals x to the eighth plus 63x to the fourth minus 3. And then the odd form would be negative g of x equals negative x to the eighth power minus 63x to the fourth power plus 3. So g of negative x would equal negative x in parentheses to the eighth power plus 63 times negative x to the fourth power minus 3. So once you solve that, it would be g of negative x equals x to the eighth power plus 63x to the fourth power minus 3. So g of x is an even function because g of negative x equals g of x. And so for a visual to help you out, it's just pointing you out. It just has all three of the types of odd function, even function, or neither, so you just know what type of function it is. I hope that helps. I did not make that, by the way. And some tips and tricks. Remember that the odd version of the equation is just the inverse of every value. So when I talk about here, so it'd be x to the eighth would be negative x to the eighth, and then 63x to the fourth minus 63x minus 3 would be plus 3. Remember that even or odd functions is not the same as even or odd degree functions. Just keep that in mind, because the degree of the function is the exponent of the highest exponent. And so just some advice. For me, the hard part was remembering that the odd version of the equation is not the same as f of negative x. Also, not always the same as f of negative x. Also, you need to remember that when negative x has an even exponent, without the leading coefficient, it is positive. But if the leading coefficient is negative, then the value is negative. So that's me wrapping up the polynomial functions, determining whether it's even, odd, or neither algebraically. So my next concept is something that I didn't do as well with. It's still in the broad concept of polynomial functions, but it's on the specific concept of determining the end behavior in zeros. This is the lesson I feel like I struggled with. So, what I usually struggle with is, just finding them. But, so right here we have the first function or equation, and it's f of x equals 13, and then in parentheses 2x plus 5, and then in parentheses x minus 3. So the zeros right here would be negative 2.5 and 3. So to find the zeros, you would go, so 2x plus 5, you would set 2x plus 5 on the side, to equal 0. So then you subtract 5, so it'd be 2x equals negative 5. Then you divide both sides by 2, so then the 0 would be negative 2.5. And then the second factor, you just add 3, and then it'd be x equals 3. So my second equation is p of x equals 7, then parentheses 8x plus 3, then parentheses 4 minus x, then parentheses x plus 19. The zeros would be negative 3 over 8, 4, and negative 19. So determine that for 8x plus 3, you would subtract 3. You would set it equal to 0, then subtract 3 from both sides, and then it would be 8x equals negative 3. So then you divide both sides by 8, so it'd be x equals negative 3 over 8. For the next one, it's 4 minus x. And notice how I wrote it. It's not x minus 4, it's 4 minus x. So if you wanted to rewrite it, it'd be negative x plus 4, which you got to remember that. So you subtract 4 from both sides, so it'd be negative x equals negative 4. If you want, what I would do is just get rid of the negative signs because they're both negative, and then just be x equals 4. But what you should do is divide both sides by negative 1, because negative x is the same thing as negative 1x. Keep that in mind. So then your 0 would be 4. And then our last factor in this equation is x plus 19. For this, you should just subtract 19, and then your 0 is negative 19. So I found this visual online. I hope it's helpful. It's just going through an equation and finding the roots. And keep in mind, roots are the same thing as zeros. So here, I didn't show you how to do it in standard form, so just ignore the top part. But yeah, once it goes from here, from x plus 3 and x minus 4 equals 0. And then set each factor to 0. And then x plus 3 equals 0, so you subtract 3, and then it'd be x equals negative 3, and x minus 4, x equals 4. So your roots would be x equals negative 3, x equals 4. So tips and tricks, just remember that when you're determining zeros, the factor is always equal to 0. And when you're writing, I actually made a mistake with this. You should be, you should be writing x equals negative 3. Like, you should be writing it like that instead of like how I did it. That was a mistake on my part. Just some advice on this. Don't get caught up with the negative signs. Just remember that the x should be positive. So the x you shouldn't write the root as negative x equals 3. It'd be x equals negative 3. And then also, zeros, roots, and x-intercepts are the same thing. It's just remember to use the right terminology because different runs are appropriate in different situations. And don't forget to graph these and learn multiplicity so you know how many total zeros there are, which will help with determining the degree of the function. So that wraps up my second point, determining and behavior in zeros from a factored function. I hope this helped, and I hope you do well in algebra class next year. Alright, thank you.